Dear friends, welcome to EPG Pathshala. I am Dr. Nitesh Goyal from DAV College, Chandigarh. Dear friends, after the completion of this module, you will be able to understand the nature and logic of hypothesis testing. You will be able to know the procedure for testing the hypothesis. You will be able to understand the overall flow of the hypothesis testing procedure. So first of all, I would like to give you a brief introduction about the topic. A hypothesis is an assumption that is tested from its logical or empirical consequences. A hypothesis should be clear and accurate. The two hypotheses, that is null and alternate hypothesis, enable the user to verify the testability of an assumption. It is possible to determine whether the hypothesis is appropriate or not with the help of hypothesis tests such as parametric and non-parametric test. In this unit, you will learn about the meaning and need for testing of hypothesis. You will also learn about the concept of hypothesis testing and the various types of statistical hypothesis. Hypothesis, according to Theodorson, a hypothesis is a tentative statement asserting a relationship between certain facts. Kerlinger also describes hypothesis as the conjectural statement of the relationship between two or more variables. Black and Champion have described hypothesis as a tentative statement about the unknown statements, that is not explaining how the variables are related to each other. There is no hypothesis in scientific sense. Hypothesis simply means an assumption or some supposition to be proved or disproved. For a researcher, a hypothesis is a formal question that he intends to solve. Thus, a hypothesis may be defined as an assumption or proposition or a set of propositions set forth as an explanation for the occurrence of some specified phenomena. A research hypothesis is usually a predictive statement which is capable of being tested by the application of some scientific methods that relates an independent variable to some dependent variable. For instance, the statement like students who receive counseling will show a greater increase in creativity than students not receiving the counseling, or the automobile A is performing as well as automobile B are capable of being objectively verified and tested. Thus, it can be concluded that a hypothesis states what we are looking for, and it is a proposition which can be put to a test to determine its validity. Now, the need for hypothesis. The need for hypothesis is illustrated in the following points. First, the hypothesis indicates the point to the investigation and gives the direction on the study. Second, a hypothesis specifies the sources of data that shall be studied and in what context they shall be studied. Also, it determines the data needs. Hypothesis also suggests the type of research that is likely to be most appropriate. A hypothesis also contributes to the development of the theory. Now we come to the characteristics of hypothesis. Hypothesis must possess the following characteristics. Hypothesis should be defined clearly and precisely. If it is not done so, the inferences drawn on its basis will never be reliable. Second, hypothesis formulated should be such that capable of being tested. If we formulate such hypotheses that are not testable, it may lead the whole research down. To avoid such situation, a prior study may be conducted by the researcher in order to make hypothesis a testable one. A hypothesis is testable if other deductions can be made from it, which in turn can be confirmed or disproved by the observation. Third, If a hypothesis happens to be a relational hypothesis, it should clearly state the relationship between the dependent and the independent variables. Fourth, hypotheses should be specific and must be limited in scope. Narrower the hypotheses are, comparatively they become more testable, and the researcher should develop such hypotheses only. Fifth, hypothesis should be stated in most simple terms as far as possible so that it is easily understood by all. But one must not forget that simplicity of hypothesis does not dilute its significance. 6. The hypothesis should be consistent with most known facts, that is, it must be consistent with a substantial body of established facts. In other words, it should be one which is accepted as being the most likely. 7th, the hypothesis should be put to testing within a stipulated time. There is no point in using an excellent hypothesis if the same cannot be tested in the reasonable time. Lastly, hypothesis must explain the facts that actually gave rise to the need for the study. In other words, by using the hypothesis along with other known and accepted generalization, one should be able to deduce the original problem condition. Thus, hypothesis must actually explain what it claims to explain, and it should have empirical references to support that. Now, some of the basic concepts that concern the testing of hypothesis. Some of the basic concepts in the context of testing of hypothesis are, first of all, the most important, the null hypothesis and the alternative hypothesis. If we are to compare method A with method B about its superiority, and if we proceed on the assumption that both the methods are equally good, then this assumption is termed as the null hypothesis. As against this, we may think that the method A is superior or the method B is inferior. We are then stating what is termed as alternative hypothesis. The null hypothesis is symbolized as capital H with a small o, and the alternate hypothesis is symbolized as capital H with a small a. Suppose we want to test the hypothesis that the population mean, that is mu, is equal to the hypothesized mean, that is mu HO is equal to 100. Then the null hypothesis is that the population mean is equal to hypothesized mean 100 and symbolically can be expressed as null hypothesis colon mu is equal to mu HO is equal to 100. If the results do not support the null hypothesis, it should be concluded that something else is true. In other words, the null hypothesis is rejected here. If we accept the null hypothesis, then we are rejecting the alternate hypothesis, and if we reject the null hypothesis, then we are accepting the alternate hypothesis. Let us take a summarized view of both the hypotheses. The null hypothesis, while comparing two different methods in terms of their superiority, wherein the assumption is that both the methods are equally good, is called the null hypothesis. It is also known as the statistical hypothesis and is symbolized, as already told, capital H with a small o. The second hypothesis is the alternate hypothesis. While comparing two different methods regarding their superiority, wherein stating a particular method to be good or bad as compared to the other one is called as an alternate hypothesis. It symbolizes, as already told, capital H with a small a. It is important to frame the null hypothesis and the alternative hypothesis before the sample is drawn. In the choice of null hypothesis, the following considerations are usually kept in view. First, the null hypothesis is the one which one wishes to disprove, and alternate hypothesis is usually the one which one wishes to prove. Thus, a null hypothesis represents the hypothesis we are trying to reject, and alternative hypothesis represents all other possibilities. Second, if the rejection of a certain hypothesis when it is actually true, it is taken as null hypothesis because then the probability of rejecting it when it is true is alpha, or the level of significance which is chosen very small. Third, the null hypothesis should always be specific. That is, it should not state about or approximately a certain value. Generally, in hypothesis testing, the research is proceeded on the basis of null hypothesis, keeping the alternative hypothesis in view because if null hypothesis is true, one can assign the probabilities to different possible sample results. But this cannot be done if we proceed with the alternative hypothesis. Now, let's compare the null hypothesis with the alternate hypothesis. Friends, following are the points of comparison between the null hypothesis and the alternate hypothesis. First, the null hypothesis is always specific, while the alternate hypothesis gives an approximate value. Second, the rejection of null hypothesis involves great risk, which is not in the case of alternate hypothesis. Null hypothesis is more frequently used in statistics than alternate hypothesis because it is of more specific nature and is not based on probabilities. The second important concept under hypothesis testing is the level of significance. It is always some percentage, usually 5%, which should be chosen with great care, thought and support of valid reason. If a significance level at 5% is taken, then this implies the null hypothesis will be rejected when the sampling result has a less than 5% probability of occurring if null hypothesis taken as true. In other words, the 5% level of significance means that the researcher is willing to take a 5% risk of rejecting the null hypothesis when it happens to be true. Thus, the significance level becomes the maximum value of the probability of rejecting the null hypothesis when it is true and is usually determined in advance before testing the hypothesis. The third concept is the test of hypothesis. Given a hypothesis, null hypothesis and an alternate hypothesis HA, a rule is developed which is known as decision rule. It is this decision rule on the basis of which we accept or reject the null hypothesis. For example, if null hypothesis is that a certain lot is good, there are very few defective items in it, against the alternate hypothesis that the lot is not good or there are too many defective items in it, then we must decide the number of items to be tested and the criterion for accepting or rejecting the hypothesis. We may test any of the 10 items in the lot and plan a decision that if there are none or only one defective item among the 10, null hypothesis will be accepted. Otherwise, null hypothesis will be rejected. The next concept is the errors. In the context of testing of hypothesis, there are basically two types of errors. One is that the researcher may reject the null hypothesis when null hypothesis is actually true and known and is then known as type 1 error. The second type of error is when the researcher accepts null hypothesis when in fact null hypothesis is not true, and this error is known as type 2 error. In other words, type 1 error occurs when we reject a hypothesis which should have been accepted, and type 2 error occurs when we accept a hypothesis which should have been rejected. Type 1 error is denoted by alpha and type 2 error is denoted by beta, the two-tailed and the one-tailed test. In the context of hypothesis testing, these two terms are very relevant and used very often, and thus making it important to understand clearly. A two-tailed test rejects the null hypothesis if, say, the sample mean is significantly higher or lower than the hypothesized value of the mean of the population. Such a test is suitable when the null hypothesis is some specified value and the alternative hypothesis is a value not equal to the specified value of the null hypothesis. The acceptance and rejection regions in the case of a two-tailed test with 5% significance level are presented here in the diagram. If the significance level is decided at 5% and the two-tailed test is to be used, the probability of the rejection area will be 0.05, which is equally split on the both tails of the curve as 0.025, and that of the acceptance region will be 0.95 as shown the above curve. If we take mu is equal to 100 and if our sample mean deviates significantly from 100 in any of the two directions, then the null hypothesis should be rejected. But if the sample mean does not deviate significantly from mu, in that case null hypothesis shall be accepted. But there are situations when one-tailed test is most appropriate. A one-tailed test would be applied when we are to test, for instance, whether the population mean is either lower or higher than some hypothesized value. For instance, if our null hypothesis is mu is equal to mu of null hypothesis and alternate hypothesis is mu less than the mu of null hypothesis, when we are interested in what is known as left tail test, wherein there is one rejection region and only on the left tail, as illustrated in the diagram. If our mu is equal to 100 and if our sample mean deviates significantly from 100 in the lower direction, null hypothesis should be rejected. Otherwise, we shall accept the null hypothesis at a certain level of significance. If the significance level in the given case is kept at 5%, then the rejection region will be equal to 0.05 of the area in the left tail as has been shown in the curve. In case our null hypothesis where mu is equal to mu of null hypothesis and alternate hypothesis, mu is more than the mu value of alternate hypothesis, we are then interested in what is known as one-tail test right tail, and the rejection region will be on the right tail of the curve as shown in the figure. So, after having a detail on the concepts, let us have the procedure for hypothesis testing. To test a hypothesis means to find out whether the hypothesis is valid or not. In hypothesis testing, the main focus area is to know whether to accept the null hypothesis or not. It includes all those steps that are undertaken for making a choice between the two possible actions, that is, the rejection and acceptance of a null hypothesis. The various steps involved in hypothesis testing are stated below. First, making a formal statement. The first step is to make a formal statement of the null hypothesis and also of the alternate hypothesis. In other words, both the hypotheses should be clearly stated. For example, an engineer wishes to test the load bearing capacity of an old bridge, which must be more than 10 tons. In that case, the hypothesis can be stated as under the null hypothesis where mu will be equal to 10 tons and the alternate hypothesis where mu is more than 10 tons. The formulation of hypothesis is a very important step which must be accomplished with utmost care and in accordance with the objectives and nature of the study under consideration. It also indicates whether the researcher should use a one-tailed test or a two-tailed test. If an alternate hypothesis is of the type greater than or the type lesser than, a one-tailed test must be used. But when an alternate hypothesis is of type whether greater or smaller, then we use a two-tailed test. Step number 2. Selecting a significance level. The hypotheses are tested on a pre-specified level of significance. Generally, either 5% level or 1% level is adopted for the purpose. There can be different factors which may suggest choosing a specific level of significance as first, the magnitude of the difference between the sample means, second, the size of the samples, third, the variability of measurements within samples, and last, whether the hypothesis is directional or non-directional. A directional hypothesis is one which predicts the direction of the difference between, say, the means. The third step, deciding the distribution to use. When the level of significance has been decided, the next step in hypothesis testing is to determine an appropriate sampling distribution. The choice generally remains between the normal distribution and the t-distribution. The step 4, selecting a random sample and computing an appropriate value. Another step is to select a random sample and compute an appropriate value from the sample data concerning the test statistic utilizing the relevant distribution. In other words, draw a sample to furnish the empirical data. The fifth step, calculation of the probability. Now, one has then to calculate the probability that the sample result would diverge as widely as it has from the expectations if the null hypothesis were in fact true. The last step in hypothesis testing is to compare the probability calculated in the previous step with the specified value of alpha, that is the significance level. If the calculated probability is equal to or smaller than the alpha value in case of one-tailed test and alpha upon 2 in case of two-tailed test, then reject the null hypothesis or accept the alternative hypothesis. However, if the calculated probability is greater, then accept the null hypothesis. Now friends, after having understood all the intricacies of the hypothesis, now it's time to summarize. The present module describes the meaning of hypothesis, which is the basis of almost every research, especially in social sciences. Hypotheses are the propositions that a researcher makes and later proves it on the basis of data collected and analyzed. There are two types of hypotheses, that is null hypothesis and the other is termed as alternate hypothesis. To prove a hypothesis to be true, a researcher needs to apply certain tests like t-test, z-test, f-test, etc. and a proper set of steps are required to be followed. On the basis of these tests, only a hypothesis is either accepted or rejected. Thank you.